This part is once again a pattern recognition kind of question, and the good thing is the question already told me that it is a geometric progression. According to what we have discussed in our topical outline, it is sometimes good to reorganize information that is given by the question into a form of a table in order for us to recognize pattern, and this is especially useful when it comes to a two-dimensional kind of pattern according to what we have discussed before. Well, I'm going to apply it here, although this is actually not such a complicated scenario. What we want to look at it is at the end of every month, what is the total value that is going to be in Mr. B's account after the interest is being given to him. Okay, so in the beginning of the month, he is going to put in $100. By the end of the month, 0.5% interest is going to be given. So the money is going to grow from 100 to 100 multiplied by 1.005. Okay, because it is a 0.5% interest that is going to be given. So by the end of the second month, in the beginning of the month, he's going to have 100 and 1.005. He's going to put in another 100. And then this entire amount is going to be increased by 1.005. If I were to reorganize this, I can actually rewrite it as 100 times 1.005 plus 100 multiplied by 1.005, this times this, so 1.005 square. It is pretty obvious that it is a geometric progression. Okay, let's just try to go for one more row in order for us to verify that it is really a geometric progression. Okay, because it's usually good to see the pattern appearing at least 3 times. Okay, so this is the amount that I will have, that Mr. B is going to have, not me, okay? What Mr. B is going to have at the beginning of the third month. So this, and he's going to add in another $100, and by the end of that month, he's going to get an extra 0.5% in terms of interest, so 1.005. If I were to expand this 1.005, multiplying into what I have here, this times this is going to get me a 100 and 1.005. This times this, it is 100 and 1.005 square. This times this, 100 1.005 to the power of 3. This is a geometric progression with the first term as 100 times 1.005, and the common ratio, it is 1.005. What we want to do is to deduce this for the nth month. So applying the geometric progression sum of GP formula, it will be the first term. We then multiply by the common ratio 1.005 to the power of number of terms. When it is the first month, it is 1 term. When it is the second month, it is 1, 2, 2 terms. Third month, it is 1, 2, 3, 3 terms. So n month, it is going to be n number of terms. So this to the power of n minus 1 divided by the common ratio 1.005 minus 1. If I were to simplify this is going to get me the expression that the question is asking me for. This is 20100 multiplied by 1.005 to the power of n minus 1. And what we need to do next is to hence find the month when Mr. B's account is going to be first greater than $5,000, which means that we are going to let this be bigger than 5,000. So I'm going to let 20100 1.005 to the power of n minus 1. I'll let this be bigger than 5,000. And since n over here that we are talking about, it is the number of months, it is an integer value. So I'm going to make use of table, just like what we have done in part 1, to solve for the least possible value of n. By pressing this into the y1 of my graphing calculator, replacing n by x, I can generate a table where x is actually n, when the y1 is this entire expression here on the left hand side of my inequality. So this to the power n minus 1. If I were to scroll down the table, when it is at 44, the value here is 4932.4. When it is at 45, the value of y1, which is this expression, is 5 057.6. So this is already bigger than 5,000. And when it is at the 46th month, this is 5183.4. Okay, they are all going to be bigger than 5,000. So the least possible n is 45. And that is why by the end of the 45th month, that is when Mr. B's account is going to be first greater than $5,000.